Let's talk about the concept of one sample confidence interval. In this video, I would like to talk about proportion. In the previous video, we already talked about the one sample confidence interval for the Z procedure and T procedure. So start right off the bat, the characteristics of a proportion problem is you will see a sample size n and the number of success x. There is no mean, no variance, and no standard deviation. So there are two things that we have to know. The first thing is population proportion, so which is a proportion based on the population. So this is a number that we don't know. And again, confidence interval is a method of inference. Inference means we are trying to guess what the true population proportion, the P is. So the P, we don't know what it is. We are trying to guess what it is using what? Using a sample proportion, which is the P hat you see on the right. So the hat on top of a P in statistics, the hat means estimation. So P hat is x divided by n, and x is the number of success, and then n is the sample size. So let's say you have a random sample of 10, let's make it big. You have a random sample of 50 college students, and then 30 of them drive to school every day. So this is a sample proportion. So out of 50 students, 30 of them drive to school every day. And then other than that, you can say I have 100 students in a class, and then 34 of them got an A in that class. So that is another proportion. So proportion, the smallest proportion you can find is, so you have 100 students in a class, nobody got an A. So that is the smallest proportion you can find, which is 0. And the highest proportion is 100 divided by 100, which is everybody got an A. So that's how you find a proportion. And then what about Q? Q is the Q. So for the P and Q, so back in still remember the binomial distribution. So binomial distribution, P is the number of is the probability of success, and then Q is the probability of failure. So usually when I teach proportion, I don't really use the Q hat. All I introduce is the P hat, because the P hat is the number of x is the number of success, and then Q, the opposite of success, is the number of failure. And I don't think you will need that to do analysis. So let's jump right into the formula. So the formula to calculate a confidence interval for a proportion procedure is P hat plus or minus Z half alpha, and then times the square root of P hat times 1 minus P hat divided by the sample size. And then the way we build a confidence interval is we start with a point estimate, and then we add and subtract margin of error. Another name of margin of error is called the error bound. So regarding the basic concept of a confidence interval, how's the point estimate, the margin of error works, how do I define them, you have to watch the video where I introduce the basic concept of confidence interval regarding a Z procedure. So in that video, I gave you the definition of all of them. Now, so back to this formula. What do you see? Do you see that we are not using Z, we are using T. Sorry, we are not using T, we are using Z. So why? Looks like when you do proportion, we are using Z right now. So looks like there is a relationship between the proportion and the normal distribution, right? Because Z stands for a normal curve. So when you use Z, you are using normal distribution. So here is the relationship. Using the large sample method, we will assume the normal curve is a good approximation to the binomial distribution. If these two conditions are met, you take the sample size times the sample proportion is greater than 5n, you take the sample size times 1 minus P hat greater than 5. If they are met, then the sampling distribution of P hat can be approximated by normal distribution. So that means the sample size must be large enough. When you take the sample size times the proportion, so what is P hat? P hat is x divided by n, right? And then you take n times x divided by n. Do we agree that considering the algebra, the n will be cancelled? So basically you have x greater than 5. So when the number of success is big enough, the sampling distribution of P hat can be approximated by normal distribution. And the following notation, some textbook might ask you to put this on your paper. So the P hat can be approximated by normal distribution, or you can say P hat, the sampling distribution of P hat follows normal distribution. with a mean p hat, and then standard error, which is the square root of p hat times 1 minus itself divided by n. And then to give you a picture of that, so we have a normal distribution. So just like central limit theorem, I keep taking samples. So I have n1, n2, n3. So sample number 1, sample number 2, and sample number 3. For each sample, I have a number of success, so x1, x2, x3. And then for each sample, I have a sample proportion. So p1 hat is equals to x1 divided by n1, and then p2 hat is equals to x2 divided by n2, so on and so forth. So if you have many samples, that means you have many p hats, right? So for each p hat, you obtain a value, a fraction. Fraction means you have a number. So what is the distribution of those p hats? So you have a bunch of p hat. What is the distribution? The distribution is normal, but as long as n times p hat is greater than 5, n times 1 minus p hat is also greater than 5, then the distribution of p hat is normal, with mean equals to p hat and standard error equals to the square root of p hat times 1 minus itself divided by n. That's why you say p hat can be approximated as normal distribution with mean equals to p hat, and then standard error of that p hat 1 minus p hat divided by n. But in order to achieve this, you have to check this, right? Usually this is satisfied. Usually, okay? Usually this is satisfied. All right, so that is the basic concept of one sample confidence interval using the proportion. In the next video, I will show you how to construct this kind of confidence interval using your calculator. I see you in the next video. Signing out for now.